Today we are joined by Ellen from JNCC and she works in the marine management team. And the talk today is understanding the scale and distribution of the impacts associated with abandoned, lost, or discarded fishing gear on benthic habitats and species. So without any further delays, off to you.
So I'm going to talk to you today about a project that I led last year. So the project is, as Victoria's just said, understanding the scale and distribution of the impacts associated with ALDFG, or abandoned, lost, and discarded fishing gear on benthic habitats and species. So this was funded by DEFRA's Impacts Evidence Group, ran from September last year to March this year, so quite a short timescale on the project. We took the work, undertook the work in-house, and we had a steering group with representatives from the ALBs and government. Um, so just before I go into the details of the project, I'm just going to give a brief kind of description of what ALDFG is. So we've got a definition from the FAO, and this breaks it down into the different kind of component parts of it. So um, fishing gear can either be abandoned, lost, or discarded, and that's all encompassed within this term. So abandoned gear could be that which is left deliberately at sea, even though it could be retrieved. Um, Lost fishing gear, so that which has been accidentally lost, but it can't be located or retrieved. And discarded fishing gear, so that's where it's been released at sea, pretty much on purpose. So there's not been any attempt to recover it. So there are lots of different types of fishing gears in use around the world. So there's lots of different kinds of ALDFG that we can get. So things like fishing line, rope, fishing net. So knowledge on abandoned, lost, or discarded fishing gear around the UK is currently pretty limited. There are a number of schemes and initiatives which are working to remove it from UK waters. But in addition to wanting to remove it, we also need to try and identify and prevent it from entering the marine environment in the first place. So this is kind of where the project's come about from. So there are different causes of abandoned, lost, and discarded fishing gear, and those can be split down into the different types that we've just covered. So gear may become abandoned due to snagging on underwater obstructions. So that might be rocks, shipwrecks, offshore industry related installations, IUU, so illegal, unreported, unregulated fishing can also cause it to become abandoned, and health and safety considerations of fishing vessels and fishermen. Gear can become lost from snagging instances, bad weather, operational error, gear conflict. So that's where static and mobile uh, gears, fishing gears, come into contact, and there can be kind of gear conflict associated with that. Um, and discarded fishing gear can come from vandalism and just illegal disposal or discarding of gear over the sides of boats um, or at sea, essentially. Um, so these different types of causes are something that we've explored within the project. So I'll just go on now to tell you a bit more about the aims and objectives. So the aim of the project was to build knowledge on the distribution of ALDFG to estimate the spatial areas most at risk from being impacted by the pressure, and to better understand where mitigation options can be applied to reduce the impacts on the marine environment. So we had three objectives for this. So firstly, we identified the areas of highest vulnerability to the occurrence and impacts. Secondly, we wanted to identify the net benefits of mitigation measures. This ended up actually um, being more of a kind of ghost fishing mortality calculation, but I'll touch on that later. And then the third objective was to recommend priority areas for action and suitable mitigation and management options. So the project had a UK-wide scope, but the case studies that we included were focused on Secretary of State waters because it was funded by DEFRA. But the aim of the project overall was to make sure it was applicable for the whole of the UK. So as you'll see later on, all the data we used was at a UK-wide scale. And the causes I've just touched upon on the previous slide were therefore quite a key part in of being able to identify these areas that are most at risk within our aims and objectives. So we looked at a number of those, which help come on to later on. So just touching on the methods. So we collated data on records of abandoned, lost, or discarded fishing gear, and data on the potential causes. And within that, we also looked at effort data and absence data for the records. The data we collated came from a range of different projects that are ongoing from around the UK. So that included things like the Clean Atlantic Project, Ghost Fishing UK, and a range of like a massive list of data, which is all listed in the report. So we contacted all these organisations to request the data. So and then we also wanted to map the potential causes of ALDFG, as I've just mentioned. So we focused on data such as underwater obstructions, so like Annex 1 reefs and wrecks, potential gear conflicts, so that came from fishing activity data, and we used the abandoned, lost, discarded fishing gear records to kind of ground truth where these potential causes of ALDFG were occurring. So we wanted to map where all the causes were, and then map all the records and overlay them and kind of compare to see if there was any potential correlation. From the mapping, we also identified hotspots for ALDFG, and we looked at some of those in a bit more detail as case studies. We did some literature review to look at the mitigation and management options, specifically relating to what might be suitable in those areas. And then we had the ghost mortality calculation aspect of the project. So we did a short literature review to find information to help us trying to calculate this. So that included information on kind of bycatch rates and if any other calculations had been done in the past. And we ended up doing a calculation which was fairly high level and very rough, just a kind of first attempt to try and put some numbers on potential ghost mortality in the UK. So the analysis on the data, we had Seabed ALDFG and beach ALDFG, and we analysed these both separately. And for both of these, we had to we translated the records into, for the Seabed records, we translated them into a standardized list based upon the ICES marine litter vocabulary. For the beach data, this came from the Marine Conservation Society's Beach Watch programme. So for that, we grouped those into the main types of ALDFG. And on these records, we analysed these using ArcGIS and did a gridded analysis using using a spatial drawing tool. So we counted the number of litter items within a spatial grid. So we used a hex grid for this, and focused on the most recorded litter types. So that was rope, net, and netting and fishing line. We also encompassed a survey effort within this to ensure we didn't have too much survey bias. Um, so there's a bit more. I won't go into too much detail, but there's a lot more information on how we did this in the report. But yeah, I just want to emphasize that effort data was considered. And for the so yeah, so for the ALDFG records, we did a kernel density analysis to produce hotspot maps. We did a similar thing for the obstructions data, to highlight the areas where there was greater risk from obstructions. And for the fishing data, we did some weighted sum analysis or intersect analysis, depending on the data set. And that was to see where the overlap was between different types of fishing gears in order to see where potential gear conflict was occurring. Okay, so I think it will make a bit more sense when I show you some maps. So I wanted to spend a bit of time showing you the main outputs of the project. So we basically produced a big report, and I mean, I say it was a big report. It was mainly included a lot of maps. So there's a lot of maps I'm going to show you now, which set out the results of the project. So firstly, I'm going to touch upon the Seabed, the Seabed ALDFG hotspot maps that we produced, and then I'll go on to the beach maps. So just the maps on this page are really just a kind of introductory maps to show you where we've got our survey data, and the presence and absence data sets that we used for calculating the kernel density maps I'm going to show you in a minute. So we had a pretty good UK-wide coverage for the survey effort, but there were a few areas that were fairly data deficient. So particularly around Northern Ireland and the deep sea areas to the west of Scotland. The absence records were spread across the UK as well, but there was no kind of clear patterns associated with those records. And the presence records did show quite a higher number of records for the inshore areas of the south coast of England and Wales in comparison to the rest of the UK, particularly Scotland and Northern Ireland again. So these are mainly due to gaps in data coverage. So here are some of the kernel density maps that we produced. So we use these to then highlight where the potential hotspots were for ALDFG. So these are split into different types. So we've got a map on the top left showing all the different types of ALDFG. So, and then this is broken down into different types. So we've got one for rope, one for fishing line, one for fishing net. So in the report, we've used the term hotspot quite a lot. So that was used to describe the areas of the highest densities of records. So the scales across all the maps were standardized. And we therefore defined the hotspots for seabed ALDFG as areas where there was more than 0.041 items per kilometre effort. So that's the middle category on the on the maps that you can see. So this one, and that's, as I said, the standardized, so it applies to across all the maps that I'm going to show you on this page. So hopefully you can kind of see some patterns coming out. So the map for all seabed ALDFG obviously showed that there was some really key hotspots around the south coast of England and Wales, and also North Norfolk is coming up as well. Also, just to note, the Canyons MCZ is another hotspot that came out. In Scotland, there were no hotspots coming through, but I kind of touched upon that, and that's probably due to the data, that kind of gaps in the data that we had. So yeah, and so some of the patterns are coming through also on the other different types that we've got here. So fishing line, for example, has got quite a hotspot in North Norfolk. Just to say that 44% of all the ALDFG categories were for fishing line, and 27 were for rope, and 9% were for netting. So that's kind of why there's not much kind of coming through as a hotspot for fishing net alone. So moving on to beach ALDFG. So for this, we had some similar hotspots coming out, but quite notably absent there was not a hotspot in North Norfolk for any of the beach categories. And so hotspots for beach were also a lot more widespread. So as well as being in the kind of same area, they also were off Essex as well, and along the southeast. Just to say, these categories were also standardized, and again we had the middle category as what we defined as our threshold for being a hotspot. These three were standardized slightly differently because there was much lower densities for all of these types of beach ALDFG, but we decided they were quite important to include because they're they were just kind of quite key types of gears. Yeah, not much to say here, just that there was no hotspots due to the low densities. But I mean, the highest areas were coming out as off Yorkshire, but again, the levels are really low, so this is kind of like not too much more than 10 items and 18 items for pots and fishing wakes, hooks and lures, and that's per kilometre of effort. So then we looked at the potential causes of ALDFG. So as I said, we did some kernel density analysis on the data to pull out where the areas, kind of the hotspot areas were, i.e. where there was most risk from ALDFG occurring. So we basically overlaid, like visually compared these maps that I'm showing you here with the maps that I've previously shown you on Seabed and beach records to pull out whether there was potentially any correlation. So the industry data we split into point and line data. We didn't want to combine those to avoid any duplication. So there were so I'm just checking. Yeah, so did seem to be a correlation between the line data and some of the hotspots. So off North Norfolk, for example, we've got quite a high quantity of line and also point obstructions, and obviously that correlated with the Seabed ALDFG records that I've just shown you. And again, the wrecks and fishermen fasteners also appeared to be in similar areas to where the hotspots were occurring. So um, off um, off the Cornwall and Devon, for example. So fishermen's fasteners, I should say, are places where fishermen have snagged their gear. So then there's basically a database of where these fishermen have reported where they've having had their gear snagged. So that can include some wrecks, but also underwater obstruction, so natural obstructions as well. And the other map we had, I haven't got a label for this one, sorry. This is for Annex 1 reefs. So this, sorry if the map's quite small. So we basically there didn't seem to be any major correlations between the largest areas of reef and the seabed ALDFG hotspots. So obviously we've got the Annex 1 reefs off the west coast of Scotland, and there wasn't a lot of seabed ALDFG records around there. But it was quite hard to draw any clear conclusions on this. Obviously, Annex 1's reefs are pretty well dispersed around the UK coastline, as are the records that we had for ALDFG. And there's also quite a lot of smaller areas of reef, which are shown by kind of the point data, which aren't on this map. And there could be it could be possible that the more discrete areas of reef are the ones that are going to pose a higher risk compared to the larger areas which fishermen might know are there. So yeah, moving on to gear conflict. So another potential cause of ALDFG. So we overlaid, as I said, so as I mentioned previously, we did an intersect between demersal static and demersal mobile gear. So the areas where there's overlap between those two gear types is where there could potentially be gear conflict occurring. We did a bit of a literature review to double check that whether patterns were whether some of the patterns were actually correct, and it did seem that there were some. So, for example, around the Isle of Skye, there are some areas of potential gear conflict, and that is also known about in literature. So there wasn't, however, much correlation between the seabed ALDFG hotspots and the data in Scottish inshore for gear conflict. So there wasn't any areas where they kind of corresponded with each other. In different areas, however, there was some similarities. So for English inshore waters, there was a hotspot on the for Seabed ALDFG fishing line off the Kent coast, and there's obviously quite a lot of potential areas for gear conflict are shown on the map here as well for that, so there could be a correlation there. Data from Wales, so top right map, there was not any distinct hotspots for ALDFG in Cardigan Bay. However, there is a potential for gear conflict occurring there. So essentially, the patterns aren't always consistent. For offshore waters, the one I wanted to point out is the Canyons area here. So this is coming up as an area of potential gear conflict, and you might recall I mentioned earlier that was one of the areas where there was a hotspot occurring for the seabed Aldfg. But yeah, in other areas, for example, along the continental shelf in Scotland, there wasn't any hotspots occurring there. Okay, so the next thing I wanted to just mention and go through was our case studies that we looked at in a bit more detail. So the first one was the Canyons MCZ. So for these case studies, we zoomed into the area and looked into a bit more detail of what the potential causes could be of the hotspot being in that area. So for this case study, there seemed to be quite a lot of potential for gear conflict occurring. So you can see this with the underlying map where the redder colours are where there's a higher kind of chance of gear conflict occurring because there's a greater overlap between static and mobile demersal fishing gears. And we've also got on here the Annex 1 reefs are shown in purple. So you can see again that those are also occurring in a similar area. And the ALDFG records we have are the ones with the crosses. So all around the similar area. So this was quite a nice case study to show some potential correlations. And just to know that the Canyons is known to be an area of to kind of be a sink for marine litter. So this is partially due to the natural movement of litter into the area due to the hydrodynamic conditions, and also the high intensity of fishing activity that occurs there. So the second case study was North Norfolk. So this was an interesting one because it had a hotspot for seabed ALDFG, but not beach ALDFG. So so for this one, we also plotted up the potential for recreational angling. So that's shown on the map on here on the right. So quite a high, a high kind of probability of these of recreational activity happening. So there could be correlations there, and there's also quite a lot of Annex 1 reefs in the area, as you can see on the left map. So again, this could be a cause of the ALDFG. So yeah, so these are kind of the two potential causes that that appeared to be some potential correlation between. And just to say, this was all kind of visually within the timescales of the project. We only had time to sort of visually assess all these potential causes. So that's why I'm kind of being fairly vague about it. So the next part of the project was on looking in a bit more detail about the impacts on benthic and mobile species. So we looked at both seabed ALDFG entanglement and land-based, which I'm going to talk to you about in a minute. So this seabed entanglement data came from some underwater diver-based observations from the Neptune's Army of Rubbish Cleaners, called NARC. So they're based in Pembrokeshire in Wales, and the data covered a 16-year period where they'd done scuba diving based marine debris removal activities. So they had logged the different types of ALDFG that they had seen, and then they'd logged the species that they'd recorded dead and those that they'd released. So the majority, so 96% of the gear types observed were from recreational gear, and that isn't very surprising because obviously the divers would have been collecting data and fairly near to the shore. Of the species that were found entangled underwater, crustaceans came out top, for both being those that were found dead and those that were found and released alive. And fish were also uh, fairly high up on the numbers as well. So that was mainly dogfish, and the crustaceans were spider crabs, lobsters, and brown crabs. So both of these species groups are probably likely to become entangled when moving around, and therefore become caught in the in those ALDFG. Um, Another one to point out is the pink sea fans that are coming out in. Actually, I think pink sea fans is on my next slide, so I'll just show that to you in a second. Yeah, so for the land-based ALDFG, this data came from um, a wider range of sources. So from the Cetacean Strandings Investigation Programme, the British Divers Marine Life Rescue, and the Cornwall Wildlife Trust Marine Strandings Network. So data was from all around the UK for this, but had got a focus around the around Cornwall due to that Cornish data set we used. So these were just records of where entanglements had been observed. So we've got the associated ALDFG types, the associated species, and then the outcomes of the entanglements. So for this one, this is where pink sea fan comes up as having the highest number of entanglement instances at 33%, followed by mussels at 27% and grey seals at 18%. Seabirds came to 5% of the records overall. The numbers of pink sea fans present in each entanglement case varied quite a lot between different records. So for one record, there was 75 sea fans in a large pile of line, net and rope, but then other entanglement records only involved individual sea fans. So the so I guess it's difficult to know whether some of these entanglements occurred with active fishing gear or from ALDFG. So, for example, seals are known to interact with active fishing gear. So we can't make too many assumptions as to where the kind of entanglement occurred, or in what type of whether it was active or actually already lost gear. And a lot of the data for the entanglement outcome was unknown, but for the rest of it, it was kind of fairly even split between those that were found dead and those that were found alive. So my next slide is on the ghost fishing mortality calculations. So this was very complicated, and we did a literature review to look at how we could calculate this. We found a I should just touch upon why it's so complicated. So mainly because the fishing efficiency of ALDFG is not constant. So each type of fishing gear will behave very differently within the marine environment. So that will result in different gear types having different catch efficiency durations. So gill nets are gonna catch species quite differently to, say, trawl nets. And so this section was really mainly aiming to review and estimate the ghost fishing mortality associated with um, ALDFG in specific areas across the UK, based upon published rates of entanglement available in the scientific literature. We focused on net and netting, because that was what the data was available for in the literature. But just there is one caveat there, which is that our data that we collated for the project, which is what I showed you earlier, included all types of net or netting. So that could be trawl, could be gill nets, whereas the in the literature, the statistics we used to do this calculation were based upon gill nets. So this is very much a kind of first stab at calculation. It's very rough. So there was quite a lot of discussions with the steering group as to how we wanted to use this information. But it's potentially useful to include. So we kept it in there, but there's definitely caveats around this section. So yeah, going back to the calculation itself, we simplified an equation that we'd found in the literature, and ended up with a calculation that we could practically do. And we looked at the amount of netting or netting recorded in a specific area and times that by the entanglement rates of per meter of net. So that the first part came from our data sets, and then the entanglement rates came from the rates that we found in the literature. So I'm just going to show you two of the results for the two case studies I've already mentioned, but we did include other kind of case studies in the report for these calculations. So the first one was for the canyons. So we've got different scenarios for the so the scenarios are basically based upon different entanglement rates that we found in the literature. As you can see, the rates vary quite a lot depending upon which literature you look at, and therefore the ghost fishing mortality that could be occurring in the canyons came out quite varied. So it ranges from 50 kilograms of fish and crustaceans up to 100 kilograms of fish and crustaceans. So it's really just to set out that there's a potential for quite a lot of mortality to be occurring, but there is a lot of uncertainty present within this calculation, and quite a lot of uncertainty, and very little is known about about this. For Norfolk, again, a lot of variation. So the lowest amount was recorded as 0.3 fish and 5 crustaceans, but those low rates are probably coming from the paper itself, which only observed the entanglement rates are only over 14 weeks, whereas the other ones were for the duration of the fishing efficiency. So basically how long, so if the net's been underwater, the fishing efficiency will likely decrease over time, but it might take longer to get to zero, longer than 14 weeks, if that makes sense. So the B and C scenarios are probably more accurate. And in those instances we had, there was potential for 55 fish and 214 crustaceans to be caught. So yeah, we did some literature reviewing and summarized some potential management options for ALDFG, specifically looking at the case studies that we presented, so Norfolk and the canyons. So I just wanted to touch upon some of the the management options. So we have preventative measures, and that's where we look at reducing the risk of ALDFG occurring. So this could be spatial management measures to reduce the chances of gear conflict, and marking and tagging of fishing gear to make it more visible. Mitigation measures can come from changes in gear design to reduce the impacts if ALDFG were to occur. And remedial measures. So this is to do with removing ALDFG. So there can be there are options in both deeper water and shallower water. So, for example, for Norfolk, scuba diving based gear retrieval might be appropriate, whereas in deeper waters, that's obviously not possible. So in Norway, grapnel anchors are used in deeper waters, but obviously there needs to be some consideration of the seabed impacts from those remedial measures. I'm conscious of time, so I won't dwell too much on this. And yeah, just to summarise, we we did highlight some of the quite a lot of data limitations, recommendations, and future work. So as you probably guessed, there was a lot of information that we collated for the report, and we only really touched the surface of all the data that we had. There's a lot more things we could have done with it. So that's why I've covered quite a lot of information. So some of the key data limitations came from there was gaps in the knowledge, so gaps on the spatial distribution of inshore fisheries activity, for example, is very limited. There was not much data collated available for Scotland, for example, and as I said, there was a lot not much information on entanglements and ghost fishing mortality. There was quite a few data sets that could be used for future work. So, for example, lost gear reports that fishermen will submit to the MMO, for example. And we also obviously only visually assess the data, so there could be potential to do some actual statistical analysis on the data and compare the causes and the records, and to see if there are any actual just to test those potential correlations. I guess so I guess in summary, we kind of found that there was obviously hotspots occurring in North Norfolk and off the Cornwall, Devon, south coast of Wales, and the potential causes. So there was some correlations with gear conflict, but that varied quite a lot. Annex 1 reefs at a large scale didn't appear to overlap with the records, but at those more localized levels, such as the canyons in North Norfolk, there was potential correlations coming through. And industry-related obstructions and wrecks and fishermen's fasteners also did appear to have some correlations with those hotspots. I think I will leave it there. Just to say that we produce PDF maps which allow you to click on and off the layers to look at the hotspot maps and the potential causes maps, and then we have the report, which includes all the maps that I've just shown you, and as well as the ghost fishing mortality calculations, and the rest of the information. So I'll leave it there. Does anyone have any questions? Sorry, that was a lot of information.
Okay, thank you, Ellen, for a very detailed and informative talk. We do have several questions on the Jamboard. I'm aware of the time, we might not be able to go through them all. Are you happy for me to send you them later, Ellen? And then we
Yeah,
can
absolutely.
circulate the rest of the answers to the questions we don't get to. Great. I'll just start with the first question, which is, in collating data, to what extent were those undertaking fishing asked for their input?
So we didn't have time within the project to actually speak to any stakeholders. So we didn't, we didn't speak to any fishermen. But we did have the Association of the IFCAs on the steering group, as well as the MMO. So they've got quite a lot of knowledge of the fishing activity data. So we used their knowledge to find the most appropriate data sets to use, but definitely potential for future projects to get the fishermen involved. Yeah.
Great, thanks. Someone else asked, did you use sea search records? I know there is a box to ID any litter or human-derived objects in the form, so this person asking if you used any of that data.
Yeah, we did. Yeah, that was all used. Yeah. Yeah, it was really useful.
Do you think fishermen are honest about reporting stagging gear, for example? Do you think they report every time they lose gear? Do you think that data is accurate?
So I don't think so there's like an obligation for fishermen to report gear when it's lost, but I don't think, as far as I'm aware, I don't think it's actually used very much. Um, yeah. But we didn't use that information, so there's potential to use that, but we didn't have the access to those lost gear reports.
Do the different hotspots for fishing line, rope, and net reflect the different types of species fished, do you think?
I'm not sure. We didn't look into um yeah, we didn't look into that, so I'm not sure. I can't really say much more on that.
Okay, maybe something for the future then.
Yeah.
Okay. Another question is, the data gaps around Scotland, especially the East Coast, can be partly due to the fact that diving is a lot more challenging. Being depicted as no hotspot areas could interfere with getting support for ghost gear removal. Will there be a ground truthing additional piece of work?
So there isn't any, yeah, there's not any kind of specific follow-ups projects that we've got planned for abandoned lost discarded fishing gear specifically, but we were really conscious when we were, yeah, writing the report that those patterns is not saying that there isn't lost gear present, because yeah, I mean, I've seen it myself that, it is there. So yeah, so the report is worded in a way as to emphasize that there is yeah, it's due to those data gaps. And yeah, and so Nature Scotland, Marine Scotland were both on the project steering group, so they have seen the report, so they were happy with how we'd presented it, but that is something they noticed as well.
Okay. You covered some aspects of why hotspots of ALDFG occur, but could it be linked to the origin of fishes and gear commonly used? And also, is it more related to general fishing effort? For example, more fishing equals more ALDFG.
um Yeah, yeah, there's definitely, yeah, that's a fair point. Yeah, definitely more. If there's more fishing happening, then there's going to be more potential risk. So the potential causes we looked at were just we just touched the surface really. Gear conflict and obstructions are just two of the potential causes. There is a lot more that we couldn't cover. So yeah, things like bad weather um and yeah, and those aspects that, yeah, exactly. So yeah.
Okay, another question is, you showed hotspots of gear type according to the amount of ALDFG observed. Line was the greatest and then nets least observed. Would it make more sense to map this according to impact level, i.e. do nets have greater entanglement impact than lines?
Yeah, so it is very complicated. And yeah, they don't all have the same um same level of impact. They aren't necessarily all gonna be caused from the same way. So I guess nets are gonna maybe get entangled more easily than, say, other gear types. It depends where the gear types are being fished. So um, some fishermen will target wrecks to fish around those and use those to kind of um, um, to benefit their fishing. So there's a lot of intricacies and complications with around abandoned, lost, discarded fishing gear. So yeah, I think until we started it, we didn't really know like how big an area it was, but it's quite complicated. So yeah, lots more to explore that we couldn't really touch upon in the report.
What caveats would you associate with these maps? Do you think there are hotspots / gear types that are underrepresented in this study?
Yeah, I think it would probably come down to yeah, because I guess a lot of the data is focused from on the inshore, so it's come from kind of scuba diving based observations. So the way that the data is collected across the UK is so from the inshore to the offshore, for example, is quite different. Um, so there's definitely a lot of caveats, with the maps. And I think yeah, that our main point of the project was really just to do a first stab at kind of mapping it all and having a look at the potential causes. And we only really scratched the surface. So um, and yeah, as I said, we only visually compared. So the way that we've written the report is emphasizing that uncertainty, but it was just really a kind of a first look, because this hasn't really been done before.
Yeah, it's a good starting point for further work.
Yeah.
So I've got two similar questions I'm going to try and bring together. The first one is, thanks, that's really interesting talk. Are you planning to publish this so your results can be widely accessible? And the second one is, how will the information in the report be used in the future to mitigate ALDFG, the issue of ALDFG?
So it is no, it's not published yet, but DEFRA have got the final copies. So it is going through the DEFRA publication process. So it will be published on the DEFRA Science Search web page. So I will, I'll email out when it is publicly available. But if anyone wants to see the report in the meantime, just let me know, or any of the maps, the PDF maps that I mentioned. In terms of the management, so that is DEFRA's responsibility to decide upon suitable management options, and so we didn't go into any detail in the report as to kind of recommendations. We were really just assessing the looking at the kind of the options. Um, yeah, so I can't say how it will be used, but hopefully it will be a useful tool for DEFRA, a useful starting point. Yeah, and DEFRA were obviously involved with the steering group, so the correct teams are aware of it. So it's really in their hands now.
Okay. Moving on to another question is, managing ALDFG seems to focus more on commercial gear. Are there any mitigation / management recommendations for regional angling lines?
So I know that there are those. I think there's there's a kind of a project that's run by anglers to do with responsibly kind of getting rid of their gear at the end of life. And you might see that there's like angling kind of recreational gear rubbish bins around the coast at different kind of sites, so like at beaches, for example. So there are kind of management measures that are being rolled out at a local level. I think it's very much that grassroots level and those organisations that are leading that. Yeah, we didn't touch upon that too much in the report, the recreational side of things. But yeah.
I'm conscious of time, so I think I'll leave that there for the Jamboard questions. I can see that Ashley's got a hand up, so if you let Ashley ask her question and then we can end there. Ashley, do you want to ask a question?
Yeah, hi, cheers. Great talk. Thanks for sharing that piece of work. It was more just, so I've been kind of involved in sort of removal of nets and things on the seabed in the past, and I mean, one of your remediation suggestions was use of scuba, but I mean, it historically has always been a licensed activity to do that if you can do it efficiently and correctly. So I was just wondering if any of the recommendations are to streamline that licensing or to actually remove it from being a licensed activity.
We included that in the report. Like we mentioned that it was licensed, as you say, but we only really briefly touched upon it. So that would be a nice recommendation. I think the point of that licensing is because in some instances it might be safer to leave the gear in situ, for example, around wrecks. You don't want to like damage any sensitive wrecks and things. So I think there was a reasoning for it, but it's quite an interesting point that there's licensing. You have to be licensed to remove it.
It's always been quite prohibitive in terms of actually trying to do good with it and get that activity to occur.
Yeah, there are some groups, some scuba diving based groups out there that are working to remove it. So they've obviously got licenses themselves. So I guess those are the kind of main.
Yeah, I mean, so it also has a fee as well involved, doesn't it? You know, like marine license application has a cost. So
Yeah.
It's crazy, but yeah, it'd be a really nice recommendation to see in there.
Yeah.
Just thanks. Just wondered if you'd encountered that or not.
Thank you.
Great, so we are at time now, so thank you everyone for your questions. There are some left on the Jamboard, so I'll send them to you, Ellen, and then once we have responded, they can circulate to everyone else. So the answers to those questions will follow up. So thank you, everyone.
Fabulous. Thank you
you,
then,
Ellen,
everyone.
as well.
And yeah, just let me know if you got any more questions. Bye bye.